In this video, we're going to take a look at what's called the demographic transition model. So it's a model that a lot of countries have followed roughly as they went from being undeveloped countries to developed countries. So we divide it into 4 stages. The first is called pre-industrial stage, and this is where birth rates and death rates are both high. So they cancel each other out and you don't get much change in the population size. Then in the transitional stage, you start to get death rate declines due to increased food production and improved medical care, but the birth rate stays high. And then in the industrial stage, the birth rate declines due to increased opportunities for women and access to birth control. And in the post-industrial stage, the birth rate is now low, as is the death rate, and population size again stabilizes. So during this transitional stage, you get a very large increase in population size, and in the industrial stage, you're still getting an increase, but that increase is slowing down. So let's take a first deeper look at the pre-industrial stage. So this is just zooming in. Here we have a timeline. This is like in the 1600s and 1700s, especially in Great Britain. We basically had a very high crude birth rate of about 40. That means 40 out of every 1,000 people. That's what crude means. And 40 over 1,000 is the same as 4 over 100. So this is saying there was a 4% birth rate and annual, and also a 4% death rate. So every year, 4% of the population would die. And we can still see this in some remote areas, like in the Amazon of Brazil. All right, so birth rate, why is it high during this stage? One, there could be a lack of family planning, and what that means is there's no use of contraception. You can also have a large need for workers in agriculture, so many families could be doing what's called subsistence farming, meaning they're making just enough food or growing just enough food for themselves to subsist or last. And that requires a lot of workers. Religious beliefs could be part of it, promoting having large families. And children are seen as economic assets, or can be, meaning that they go off, they get jobs, and they bring money back to the family. We have a high death rate during this time for a number of reasons. You have high infant mortality rate, meaning many children will die as infants. Disease, famine, lack of clean water and sanitation, lack of health care. These are all basically resulting from having low levels of medical technology. And then you have war, limited food supply, and lack of education. These are all contributing to high death rate. So the population change that we see is actually not much. It's a pretty stable population. Population growth rate can be less than 1%, meaning the doubling time could be about 100 years. This is a typical age structure diagram for this stage. The main thing is that it's a concave triangular, meaning that we're still seeing a lot of death between this age bracket and the next age bracket up, and we're seeing that death causes it to kind of cinch inward or cave inward like this. And so this is also associated with short life expectancy. Let's go on to transitional stage number 2. And so you should be taking notes for assignment 4.3, where you are drawing these stages and explaining exactly what's going on with the birth rates and the death rates and why. All right, so now transitional period. So now we're talking, for example, Britain in the late 18th century or to mid-19th century. And Kenya, and this is a typo, this should be 1880s to 1910s. Okay, well, anyways, what we have going on here is a high crude birth rate, so that's still high, but the crude death rate is decreasing. And so we see that from the green decreasing over time, and what that causes is a increase in population. So let's talk about birth rate. Remains high. So we have a total fertility rate which can be around 4.56. That would be child per woman per year. Not per year, sorry, per lifetime. And people are used to having many children, so it takes time for this culture to change. And again, religious beliefs can tie into it. The death rate, however, has decreased due to improved hygiene, improved sanitation, improved food production and storage, and improved transportation of food. So the population change is really rising quickly. And because mostly you're looking at that gap between the deaths and the births growing wider. We'll take a look at that in just a moment. So England's agricultural and industrial revolutions, which we're also experiencing here in the US, these are responsible for the increase in food availability and the increase in medical technology. And so we're getting population growth rates of around 3%, which means a doubling of the population every 18 to 20 years. And that's why we said in our last video that even elderly alive today has seen the world population triple in their lifetime. So here the age structure is a little bit more like a triangle. And so what we're not seeing here is a lot of the death that was occurring within at each age bracket. And so you're getting accelerating population growth. So that difference we talked about is the bigger the difference is between the birth rate and the death rate, then the faster your population will be increasing. So let's take a look at the industrial stage. Here we see crude birth rate starting to come down, and crude death rate also beginning, also staying low, and population still rising but not as fast. So this could be seen in Britain in the early 20th century and in Brazil and Mexico. What's causing the birth rate to decrease now? So we see now a TFR of around 2.05, which is around what we call replacement fertility rate. 2 children replacing the 2 parents. And this is due to improvements in contraceptive technology, changes in values about children and sex. So seeing sex not just as an act of procreation, and parents need fewer children as well because they're not perhaps living on a farm, and the rising costs of dependent children to a family. So families are realizing that it can be very expensive to have children, and the fewer you have, the less expensive it is for you. And women are seen as having more value than just being mothers. In terms of, I don't want to say just being mothers, that is one of the highest values in itself, but that women are giving opportunities to have careers. And working women have less time to devote to child rearing. So many women will even delay having children until perhaps their 30s or so. And the death rate is still low due to these things that we've learned about: better technology for healthcare, such as vaccinations, better understanding of the spread of diseases, prenatal care, so reducing that infant mortality rate. And we also get improved sanitation, like indoor plumbing, which can really reduce the rates of things like cholera, which were horrible diseases that were spread through human sewage back in the late 1800s, early 1900s. And you have improved quality and quantity of food. So we still get population growth now, population increasing, but at a slower rate, less than 1%. So the doubling time is now around 65 years. And we start to see age structure diagrams looking like this because of decreasing TFR, and we see a bulge in the reproductive cohorts. So like for the US here, we see a bulge that for one occurred with the baby boomers, and a narrowing of the pyramid base. So people are not having as many children, so we just don't see as many of the youth. Let's go to the post-industrial stage. And here we see low crude birth rate and low crude death rate, and the rate of natural increase is pretty stable. And so we see this in the late 20th century in Sweden and in Japan. So we have a TFR around 2.1 replacement rate. We have family planning where parents are choosing when to have children and how many. There's generally good health, improved education of women, and many marriages happening later in life. So the death rate is low due to continued better healthcare and high quantity and quality of the food supply. So what can happen oftentimes is that the TFR falls even possibly below the replacement fertility level. We'll take a look at that in the next part here. But one big thing here is zero population growth, meaning that you are having a TFR right around replacement rate. And so here we get what are often called inverted population pyramids. We have so many of these people here, the elderly, from when the population was increasing rapidly, but now we're having much fewer youth. And so even though we have much fewer youth now, it'll take some time before the population actually begins to get smaller, because it won't get smaller until many of these older generations begin to die off. So some people talk now about a fifth stage where we see the birth rate showing in green here actually declining. So many couples choosing only to have 1 or 2 children, meaning the average is going to be less than 2, less than the replacement rate. And we see this, for example, in Romania, where the crude birth rate is 10.53, but the crude death rate is 11.88. And the total fertility rate is only 1.39. So their population growth is actually negative 0.147%. So test your knowledge here. Which of the following best describes a country becoming more industrialized or more developed? Okay, so you should pause. Welcome back. So if you said D, death rate decreases, then you're right. And then birth rate decreases. And how about this? In stage 2 of the demographic transition, population growth rate, A is increasing, B is decreasing, or C is stable. Pause. Okay, so did you say that A is increasing? So we see an increasing growth rate as that death rate begins to really drop. And in stage 3, the population growth rate begins to decrease. And so I'm going to ask you, based on that, to sketch a population versus time graph for a country passing from demographic stage 1 to stage 4, or even to stage 5 post-industrial. And so this is one of the questions in assignment 4.3, where we're going to draw superimpose on top of our transition model what the population would be doing. So small population, but increasing with an ever-increasing growth rate. And as this gap gets wider and wider, until we reach a point at this blue line where now the green begins to come back closer to the red. And so this rate of population increase begins to decrease until finally that rate becomes 0. So a big question to ask is, did we exceed the long-term carrying capacity of the planet in 1985, as many estimates suggest? So we did our global footprint for ourselves at the beginning of the term, and we know now that as a civilization, we are using the resources of more than one planet that can sustain. But the tipping point there appears to be in 1985. What has allowed us to increase Earth's carrying capacity for our species? Was it agriculture? Was it industrialization? Or was it tool making? Or was it a combination of these? And so, indeed, it is all of these. Let's take a look at the general time frame. So tool making beginning maybe as long as 1 million years ago, and we see it so even with cavemen times. Agriculture beginning around 10,000 years ago, we were using domesticated animals and planting specific seeds for their cultivation. And then industrialization, which happened in the last couple hundred years with the use of fossil fuels. Can this be sustained? So we're going to mention here or discuss briefly about the wealth gap. Residents of developed nations have larger houses, more possessions, and more money than residents of developing nations. The richest 20% of the world's people consume 86% of its resources and have more than 80 times the income of the poorest 20%. we see a large disparity, a large separation in wealth. And we'll talk a little bit and do a little exercise in class about the effects of that on the environment. So one thing to point out is poverty generally means a day-to-day survival, and you're not thinking about long-term sustainability. Overpopulation in Africa's Sahel region has led to overgrazing of semi-arid lands. You're going to graze as much as you need to be able to survive, even if you're concerned or even if there's the possibility of overgrazing the land to the point that the good soil gets eroded away. And on another note, with Africa, where many of the most impoverished nations are, we see an epidemic of the HIV virus causing AIDS. And AIDS infects 1 in 5 people in southern African nations. 1 in 5, that's a huge number. It kills babies born to infected mothers. It has orphaned 14 million children because their mothers die. And it has cut 19 years off of life expectancies in parts of southern Africa. So the main point here is that HIV and AIDS is a major hindrance to the economic development of African countries, because how can you progress when you have so many sick people and orphans? How do you have people going off and getting an education and learning how to become doctors and teachers and everything else? So AIDS cases are rising rapidly worldwide. We see the HIV infections and the AIDS disease that they can cause. And on that sober note, I will leave you with one thought. Throughout history, maximum human lifetime has increased as medical care and technology has improved. True or false? So this is actually false. Although the average lifespan is much higher now than in the past, maximum lifetime used to be greater before the Industrial Revolution because primarily less pollution. And so you did not have as high of rates of cancer, which is oftentimes what can kill elderly. Okay, well, on that note, we will review some of these concepts tomorrow in class. Please come to class ready to ask questions about things that you want to clarify. Make a note of them on your paper today.